In this video, I'm going to be going over Module 12.1, Explain 2, which is on page 587, and it's graphing arithmetic sequences. So the arithmetic sequence 3, 5, 7, 15, and 19 has a final term. It's called a finite sequence. So it doesn't go on forever. It's not, forever. Its graph has a countable number of points. In fact, it has 1, 2, 3, 4, 5 points. That's a countable amount. The arithmetic sequence 3, 7, 11, 15, 19, ... right? That indicates that it does not have a final term indicated by the 3 dots. This is called an infinite sequence, and its graph has infinitely many points. Since you cannot show the complete graph of an infinite sequence, you should simply show as many points on the grid allows, or that the grid allows. So that's what we're going to be doing. We're going to be graphing these. So it says write the terms of the given arithmetic sequence, then graph. So I see that the chart here gives us the values, but how did they get these values? So here is our rule, and this is an explicit rule. The reason I know that this is the explicit rule is because it doesn't have the first term or the 0th term indicating that it would be recursive, and it also doesn't have f of n minus 1 talking about the previous. So in this explicit rule, you can take 0 and plug it in here for n. 2 times 0 is 0, minus 1 is negative 1. And that's how they got that. Then we have 1, we plug 1 in. 2 plus negative 1 is 1, and that's how they get that one, and so forth. So they're taking n and they're plugging it in right here. So we have 2 times 2, 4 minus 1 is 3. 2 times 3 is 6, minus 1 is 5. 2 times 4, 8, minus 1 is 7. And so we get the sequence negative 1, 1, 3, 5, and 7. And how come they stopped at 4? Well, right here with our explicit rule, it says from 0 to 4. So we plugged in the values 0 to 4. And then we go ahead and plot these points. 0, negative 1, 0, negative 1, 1, 1, 2, 3, and so forth. So let's see if we can do it for part B. So for part B, it says f sub 1 equals 4, and f of n equals f of n minus 1 minus 0.25. So this one is recursive, right? We start with our first term, and we're going to use the previous term in order to get the next term. So we're going to do this for when n is greater than or equal to 2. So just so you know, n is greater than or equal to 2 for infinitely many numbers, right? So it says make a table of values, bearing in mind that the table could be extended because this is infinite. So I could go to 6, I could go to 7, I could go to 8, but my chart here, or my graph here, will not allow that. So we know that the first term is 4, and plugging, let's see, f of 2, f of 2 equals f of 2 minus 1 minus 0.25. That's saying f of 2 minus 1. Well, isn't that f of 1? So we would have that this is f of 1 minus 0.25. So what is f of 1? F of 1 is 4, and they plugged it in here. So 4 minus 0.25 is 3.75. And now for the next one. So remember, you're always using the previous term to get your next one. So if I'm plugging in here, if I'm finding my third term, I'm going to plug the second term in here. So my second term was 3.75, and 3.75 minus 0.25 is 3.5. For the next one, when you're finding f of 4, you use the previous term, which is f of 3 is 3.5. 3.5 minus 0.25 is 3.25. And for this one, f of 4 we just found to be 3.25. And we subtract 0.5 and we get 3. So these are the points that we're going to plot. So 1, 4, 1, 4, 2, and 3.75. 2, let's see, this would be 3.5, so this would be 3.75. Then we have 3 and 3.5, so 3, 3.5, and 4 and 3.25, 4 and 3.25. And then I actually run out of room. I shouldn't have even plugged in 5, I guess, because I run out of room, right? And it says up here, since you cannot show a complete graph, you should simply plot as many points as the grid allows. Well, this grid kind of cut us off at 4, so there we go. And so the last part of it says, so the sequence is, and we started with 4, 3.75, 3.5, 3.25, 3, and dot, dot, dot. Remember the dot, dot, dot indicates that it's infinite, and since this says for n greater than 2, we know that that's infinite. And then we graphed it here.